What's up, everyone? The title of this problem is blank space, and it is from Codeforces. Here's what it says. You are given a binary array A of n elements. A binary array is an array of consisting only of zeros and ones. A blank space is a segment of consecutive elements consisting of only zeros. Your task is to find the length of the longest blank space. Input: the first line contains a single integer t, the number of test cases. The first line of each test case contains a single integer n, the length of the array. The second line of each test case contains n space separated integers, ai, the elements of the array. Output: for each test case, output a single integer, the length of the longest blank space. Okay, so we are told that we are going to receive for each test case an array of n elements, and each of those elements can be either 1 or 0. There are no other possible values in this case. That's why it's a binary array. Okay, so this is pretty straightforward, but I'm going to explain it very quickly because it's rather simple. All we have to do is we're going to be iterating over each of these values, obviously. And as we iterate, we can begin counting because we are looking for the uh, the longest blank space, meaning h- what is the longest chain of zeros for each test case. So for example, let's say here we get 5 test cases, and for the first one we will get 5 integers. And here it says that, for example, at first we get the value of 1, so we wouldn't begin counting because 1 is not 0, obviously. But starting from the second item, we can actually begin counting. And let's say we do something like, okay, now we have 1, and at that point, 1 would be the largest um, chain of zeros because our previous largest value or previous longest chain of zeros was literally 0 because we had just begin counting. Hope that makes sense. So then we can take that 1 and add 1 to it, so that would make it 2. And then on the fourth value, something interesting happens because our chain got cut off by this 1. But in this case, or at this point, we could just save this 2 and store it. So if we encounter a larger chain than 2, we could record it. But in this case, it's not possible because there's only 1 0 left. So we would output 2. Hope you get the idea, and let's implement it. So as usual, I have my boilerplate for the test cases because it's been pretty repetitive, at least so far. So let's see. The first line of each test case contains a single integer n. So let's say, well, let's take n, just like that. Then it says this is the length of the array. Then it says the second line of each test case contains n space separated integers, ai, the elements of the array. Now, the problem invites you to treat this as an array, and that would make perfect sense. But notice that we are given n space separated integers. So it is up to us to determine how we want to process that data. So to speak, in our case, or in this case, I want to process it not as an array, but rather on an item by item basis, meaning one at a time. And as we are getting each item one at a time, we can do our calculations because it wouldn't change a thing. So let's do that. The first thing we're gonna do is, let's say I'm going to create an integer called item, and then we're going to begin iterating n times. So we can do something like this, and then for because we expect n items, we can just start uh, taking them one at a time, just like this. And here we receive the first one, so we can begin doing our calculations. Yeah. Um, for example, once we get the item, we can determine if that given item is equals equals to zero, we have to do something, and that is to increase some type of counter. Meaning, for example, let's say we get our counter, and as I told you earlier, um, at first our counter will be zero because we don't have any data to compare it to. So, but once it encounters its first zero on the array, let's say, uh, we can start increasing it just like this. And then we have to check for other test case. For example, what if the item this time is a 1? Well, in this case, we would have to stop counting, or rather um, reset our counter because the chain got cut off. So let's do that. We could do that just like this. We're back to zero. But notice we're missing something. What if what would happen to our previously stored chain or our previously stored length of the chain? Well, we would have to save it, and for that I would need another variable called int. Let's call it max counter, for example. And at the beginning, max counter is going to be 0 as well. But here, after each 0 that appears, we can compare our current counter to the max counter, and we can say if the current counter is larger than our max counter, meaning our largest chain of zeros ever, only if this is larger, we're going to update our max counter to the current counter, just like that. So in this case, we were essentially done because we would be getting each item. We would determine if the current item is a 0. If it is, we would increase our current counter, and then we would check is our current counter larger than our max counter. If so, we update our max counter. Then, if in the case the current item is a 1, we could just reset our counter back to 0 and start over when we encounter another chain of zeros. And this would not affect the result because our max counter would have been saved by that point. By that point. So, hope that makes sense. And all that's left is to print the max counter, just like this. So let's give this a go. Nope, not like that. Okay, so let me grab the sample input, and here we get 21103. 21103. Perfect. So we might be able to submit it. Let's verify non-human as usual. Success. So let's give this a go. And let's just wait for a bit. It's in the queue. And once this gets accepted, I'll explain briefly the time complexity, although probably you have a very good idea by now what it will be. It's taking a bit too long. Let me refresh this, maybe it already got processed. No, it's in a queue. Okay, so this is awkward. Um, I mean, yeah, the thing about this problem is that you can treat the information sort of like an array or like we did in an item by item basis. And when you do that, you can implement this solution. But if you think about it, it doesn't really change a thing because otherwise you would have just saved all the values inside an array and then you would have just performed some variants or some version of what we just did. Not much would change. Wow, this is extremely slow. What the heck's going on? I might have to edit this. Uh, okay, so I'm gonna cut it here. The time complexity of this is O of n because we would have to iterate over each value out of the n ones we are given. So yeah, in order to determine like the max value. So sorry about this. I will link the submission below so that you can confirm if this actually works. That's it, and I'll see you later.